Yes, hello, welcome back. I'm John, an old YouTuber. It's Friday today and weekend. It's summer. And I'm just sitting here alone again in my apartment. But I do that because I have this debt I pay every month. I pay $1,100 to my debt, but I made a video about that. Last video I called read lists. I got one more subscribers, 15,027. But I think I will lose many hundreds subscribers if I do this. I upload many hundreds of these videos. But my last video I just called read list PDF. That's an update of my crazy read list. So I'm not going to do that again. So I did delete this part of the read list and copy to there. Then I define some new. So next is the Wankel engine, fruit press, automotive industries there. Then from 5 we go to 5.1, 5 there. Then we go back to here. So let's just, this is 40 pages. It's close to 2 p.m. and I've just charged the camcorder, it's full of power. No, the battery is full, like 95%, something like that. I just record 11 minutes this read list, so I'm not going to talk a lot because I did that last video. Let's try to adjust a bit, because every time I touch the camcorder I'm moving the camcorder a little bit. And I don't know if I have used the zoom or what. No, I have to go a little bit more back. But that's not so important because we not need to record all this. It's not important we record that. So, but that's part of the program. So actually could be closer, could be like this. But let's just record how the Adobe Acrobat is look like. So maybe this is the window there you're taking out and expanding. Yes, let's continue. I need some more cola. No, not cola, I need something to drink. Yes, that was a new credit offer. I can get more credit, like 10,000 Danish kroner. That's like $1,400 or $1,300. 10,000 Danish kroner I could get more credit, but the debt is not the big problem. The problem is my payment every month is raising. If I'm spending more credit, I have to pay every month more. I have to pay a little bit more every month. That's the problem. It's not the problem I have some kind of debt. Problem is my payment is too big. It's $1,100. So, but you cannot really get more debt and not pay every month. So, yes, but let's continue there. No, you cannot get more credit and not pay more. But normally you have to pay more every month because yes, activate voice. Read to end of documents.
Wankel engine. A Wankel engine with its rotor and geared output shaft. The Mazda RX-8 sports car is the last production car to date to be powered by a Wankel engine. Norton Classic air-cooled twin-rotor motorcycle. A Wankel engine is a type of internal combustion engine using an eccentric rotary design to convert pressure into rotating motion. Compared to the reciprocating piston engine, the Wankel engine has more uniform torque, less vibration, and, for a given power, is more compact and weighs less. The rotor, which creates the turning motion, is similar in shape to a Rulio's triangle, except the sides have less curvature. Wankel engines deliver 3 power pulses per revolution of the rotor using Otto cycle. However, the output shaft uses two-thread gearing to turn 3 times faster, giving 1 power pulse per revolution. This can be seen in the animation below. In 1 revolution, the rotor experiences power pulses and exhausts gas simultaneously, while at 4 stages of the Otto cycle occur at separate times. For comparison, in a 2-stroke piston engine there is 1 power pulse for each crankshaft revolution, as with a Wankel engine output shaft, and, in a 4-stroke piston engine, 1 power pulse for every 2 revolutions. The 4-stage Otto cycle of intake, compression, ignition, and exhaust occurs each revolution of the rotor at each of the 3 rotor faces moving inside the oval-like epitrochoidal housing, enabling 3 power pulses per rotor revolution. The displacement given in engine specifications is typically for only 1 face of 1 rotor, a single working chamber, or 1 face multiplied by the number of rotors. However, all 3 faces of all rotors are working at the same time. The engine is commonly referred to as a rotary engine, although this name is also applied to other completely different designs, including both ones with pistons and pistonless rotary engines. Contents. Concept. Design. History. Early developments. Licenses issued. Developments for motorcycles. Developments for cars. Engineering. Recent developments. Materials. Sealing. Fuel economy and emissions. Laser ignition. Homogeneous charge compression ignition, HCCI. Spark-controlled compression ignition, SPCI. Compression ignition rotary. Hydrogen fuel. Advantages. Disadvantages. Applications. Automobile racing. Motorcycle engines. Aircraft engines. Vehicle range extender. Other uses. Non-internal combustion. See also. Notes. References. External links. Concept. The design was conceived by German engineer Felix Wankel. Wankel received his first patent for the engine in 1929. He began development in the early 1950s at NSU, completing a working prototype in 1957. 1. NSU subsequently licensed the design to companies around the world that have continually made improvements. Design. The Wankel engine has the advantages of compact design and low weight over the more common internal combustion engine, which uses reciprocating pistons. These advantages give rotary engine applications in a variety of vehicles and devices, including automobiles, motorcycles, racing cars, aircraft, go-karts, jet skis, snowmobiles, chainsaws, and auxiliary power units. Certain Wankel engines have a power-to-weight ratio of 1 horsepower per pound. 2. Most engines of the design are of spark ignition, with compression ignition engines having been built only in research projects. In the Wankel engine, the 4 strokes of an Otto cycle occur in the space between each face of a 3-sided symmetric rotor and the inside of a housing. The oval-like epitrochus-shaped housing surrounds a triangular rotor with bow-shaped faces similar in appearance to a Rulio's triangle. 3. The theoretical shape of the rotor between the fixed apexes is the result of minimizing the volume of the geometric combustion chamber and maximizing the compression ratio, respectively. 4. 5. The symmetric curve. The Wankel KKM motorcycle. The O marks one of the 3 apices of the rotor. The B marks the eccentric shaft and the white portion is the lobe of the eccentric shaft. The distance between A and B remains constant. The shaft turns 3 times for each rotation of the rotor around the lobe and once for each orbital revolution around the eccentric shaft. Connecting 2 arbitrary apices of the rotor is maximized in the direction of the inner housing shape with the constraint that it not touch the housing at any angle of rotation. An arc is not a solution of this optimization problem. The central drive shaft, called the eccentric shaft or E-shaft, passes through the center of the rotor being supported by fixed bearings. 6. The rotors ride on eccentrics, analogous to crank pins in piston engines, integral to the eccentric shaft, analogous to a crankshaft. The rotors both rotate around the eccentrics and make orbital revolutions around the eccentric shaft. Seals at the apices of the rotor seal against the periphery of housing, dividing it into 3 moving combustion chambers. 4. The rotation of each rotor on its own axis is caused and controlled by a pair of synchronizing gears. 6. A fixed gear mounted on one side of the rotor housing engages a ring gear attached to the rotor and ensures the rotor moves exactly 1/3 turn for each turn of the eccentric shaft. The power output of the engine is not transmitted through the synchronizing gears. 6. The rotor moves in its rotating motion guided by the gears and the eccentric shaft, not being guided by the external chamber. The rotor must not rub against the external engine housing. The force of expanded gas pressure on the rotor exerts pressure to the center of the eccentric part of the output shaft. The easiest way to visualize the action of the engine in the animation is to look not at the rotor itself, but the cavity creator between it and the housing. The Wankel engine is actually a variable volume progressing cavity system. Thus, the 3 cavities per housing all repeat the same cycle. Points A and B on the rotor and E-shaft turn at different speeds. Point B circles 3 times as often as point A does, so that one full orbit of the rotor equates to 3 turns of the E-shaft. As the rotor rotates orbitally revolving, each side of the rotor is brought closer to and then away from fuel of the housing, compressing and expanding the combustion chamber like the strokes of a piston in a reciprocating piston engine. The power vector of the combustion stage goes through the center of the offset lobe. While a 4-stroke piston engine completes 1 combustion stroke per cylinder for every 2 rotations of crankshaft, that is, 1/2 power stroke per crankshaft rotation per cylinder. Each combustion chamber in the Wankel generates 1 combustion stroke per drive shaft rotation, i.e. 1 power stroke per rotor orbital revolution and 3 power strokes per rotor rotation. Thus, the power output of a Wankel engine is generally higher than that of a 4-stroke piston engine of similar engine displacement in a similar state of tune, and higher than that of a 4-stroke piston engine of similar physical dimensions and weight. Wankel engines ideally can reach much higher engine revolutions than reciprocating engines of similar power output. This is due partly to the smoothness inherent in its circular motion, lack of a mechanical valvetrain employing reciprocating poppet valves and the rotor spinning at 1/3 of the speed of the output shaft. The eccentric shafts do not have the stress-related contours of crankshafts. The maximum revolutions of a rotary engine are limited by tooth load on the synchronizing gears. 7. hardened steel gear serra used for extended operation above 7,000 or 8,000 rpm. In practice, Wankel engines in production automobiles are not operated at much higher main shaft speeds than reciprocating piston engines of similar. Schematic of the Wankel 1. Intake. 2 exhaust. 3 stator housing. 4 chambers. 5 pinion. 6 rotor. 7 crown gear. 8 eccentric shaft. 9 spark plug. Output power and cycle speeds, 1/3 of Wankel main shaft speed and 1/2 of 4-stroke crankshaft speed, are similar to conventional engines. For example, the 12 AM rotary in the 1970 RX2 produced peak power at 7,000 rpm, 39 engine cycles per second, 8, while the reciprocating piston engine in the same year of the same model family, Capella, produced peak power at 6,000 rpm, 50 engine cycles per second. 9. Mazda Wankel engines in auto racing are operated above 10,000 rpm, but so are 4-stroke reciprocating piston engines of relatively small displacement per cylinder. In aircraft, they are reused conservatively, up to 6,500 or 7,500 rpm. But as gas pressure participates in seal efficiency, racing a Wankel engine at high revolutions under no load conditions can destroy the engine. National agencies that tax automobiles according to displacement and regulatory bodies in automobile racing variously consider the Wankel engine to be equivalent to a 4-stroke piston engine of up to 2 times the displacement of 1 chamber per rotor, though 3 lobes exist per rotor. Because every rotor is completing only 1/3 rotation per 1 rotation of the output shaft, so only 1 power stroke occurs per working per output revolution. The other 2 lobes are simultaneously ejecting a spent charge and taking in a new one rather than contributing to the power output of that revolution. Some racing series have banned the Wankel altogether, along with all other alternatives to the traditional reciprocating piston 4-stroke design. 10. History. Early developments. The first DKM Wankel engine designated by Felix Wankel, the DKM 54, Drehkolben motor, at the Deutsches Museum in Bonn, Germany. The rotor and its housing spin in 1951. NSU Motor Work AG in Germany began development of the engine, with 2 models being built. The first, the DK motor, was developed by Felix Wankel. The second, the KK motor, was not developed by Felix Wankel but by Hans Dieter Pask. The Pask engine was adopted as the basis of the modern Wankel engine, yet named after Felix Wankel. 11. The basis of the DKM type of motor was that both the rotor and the housing spun around on separate axes. The DKM motor reached higher revolutions per minute, up to 17,000 rpm, and was more naturally balanced. However, the engine needed to be stripped to change the spark plugs and contained more parts. The KK engine was simpler, having a fixed housing. The first working prototype, DKM 54, produced 21 HP, 16 kilowatts, and ran on the 1st of February 1957, at the NSU Research and Development Department Versuchsabteilung TX. 112. The first KKM Wankel engine designated by Hans Dieter Pask, the NSU KKM 57P, Kreiskolben motor, at Autovision and Forum, Germany. The rotor housing is static. The KKM 57, the Wankel rotary engine, Kreiskolben motor, was constructed by NSU engineer Hans Dieter Pask in 1957 without the knowledge of Felix Wankel, who later remarked, "You have turned my race horse into a plough mare." 13. Licenses issued. In 1960, NSU, the firm that employed the 2 inventors, and use firm Curtiss-Wright, signed a joint agreement. NSU was to concentrate on low and medium-powered Wankel engine development, with Curtiss-Wright developing high-powered engines, including aircraft engines of which Curtiss-Wright had decades of experience designing and producing.